Today I'm going to show you how to graph y equals negative secant 2x plus pi over 3. In order to graph any trig function, we have to understand the unit circle. There are 5 points needed to graph a trigonometric function. We'll start at 0 radians, go to pi over 2 radians, pi radians, 3 pi over 2 radians, and end at 2 pi. Once you get to 2 pi, that's one full cycle around the circle. That is one period of the graph. Here are the points on a graph. Now we have these two numbers, 1 and negative 1. That is the amplitude of the graph. The amplitude is 1 because when you are at 0 radians, cosine is 1. Then when you go halfway around, when you're at pi radians, cosine is negative 1. Therefore, the amplitude will be 1. And now we have our basic cosine graph. When radians is 0, cosine is 1. When radians is at pi over 2, cosine is 0. When radians are at pi, then cosine is negative 1. When radians are at 3 pi over 2, cosine is 0. And then when you get to 2 pi, you make one full period, and that is when cosine equals 1. Here is your basic y equals cosine x graph. Now we must understand that secant x is simply 1 over cosine x, which means that we're going to have major domain restrictions. Because you cannot have a 0 in the denominator, cosine x cannot equal 0, which means there will be asymptotes on our graph. These asymptotes will occur at pi over 2 radians and 3 pi over 2 radians, because on the unit circle, when you're at pi over 2 radians, cosine is 0, and when you're at 3 pi over 2 radians, cosine is also 0. Therefore, there is a domain restriction and there are asymptotes at those spots. When you plug in points that are very, very close to pi over 2, the graph approaches infinity. When you plug in points that are very, very close to 3 pi over 2, the graph also approaches infinity. Therefore, this is what the top of the graph will look like. Down here, it's the same thing except it's approaching negative infinity. Therefore, there's a parabola at the bottom of the graph. This is your basic y equals secant x graph. Now let's look at our graph y equals negative secant 2x plus pi over 3. Because the amplitude is 1, but it's a negative 1, the graph will be inverted. The 2 in front of the x indicates that there will be a period change. To find the new period, simply set 2x equal to 2 pi, which is a period of a usual graph. Divide that out and you'll get x equals pi, which is the new period. Finally, the pi over 3 right here indicates that there will be a phase shift, pi over 3 to the left. In order to find the new points, first of all, we need to start by factoring out a 2. Then you'll get 2 in parentheses x plus pi over 6. Set that value equal to your original 5 points. Then you will divide by 2 and get x plus pi over 6 equals 0, pi over 4, pi over 2, 3 pi over 4, and pi. Notice that the last number is the period that we found earlier. Now we will complete our phase shift by subtracting pi over 6 from each point. Now our new points are negative pi over 6, pi over 12, pi over 3, 7 pi over 12, and 5 pi over 6. Now we can graph our secant graph. First, we'll start by graphing our guide curve. The guide curve is simply y equals negative cosine 2x plus pi over 3 instead of y equals negative secant 2x plus pi over 3. Now we graph our asymptotes, where cosine equals 0. Using the guide curve and the asymptotes, you are now able to graph y equals negative secant 2x plus pi over 3. This is the final graph.